Hello, guys. Good morning from here. So, today we are going to be doing some more problem solving in Rust, and we have another beginner task to do. It's called a duplicate line finder. So, the program takes a file path and prints every line that appears more than once in the file, along with how many times it appears. So, for example, we have a file with multiple lines of fruits. So, some of these fruits appear more than once. So, our program is to go take a file path like this, go through the file and print the lines and that appear more than once and how many times each entry appears. Okay, so we're going to start on a blank page and code from there. So this is going to be a command line program. So if this is CLI duplicate line finder. So if you're starting the program, we do cargo run. But if we want to start the program with some input or arguments, we add them after the double dashes. So let's say this is it, right? This is what we start the program with, and this will be our file path depending on what you have. So this is supposed to be put in the root folder of your program. So first of all, because this is a program that is going to be started with some arguments from the command line, let's store our arguments somewhere. So let's create a variable called args again, and it's going to be coming from our environment. So we use the env environment module from the standard library. So as you can see, entering env and hitting enter, it automatically puts the use standard library env module. So what do we want to use from the module? It's the args, which is an iterator that returns the arguments that this program was started with. So we need to store this in a collection, because our arguments are not just one. It's going to be multiple arguments, as we'll see. So let's put a type notation here. So it's going to be a vector, right, of string, because those are the kind of inputs we add. And because this is a collection type, we need to use a method here. As you can see, it transforms an iterator into a collection. So this is now transformed into this collection. Let's end this here. Okay, so we now have a variable to store our arguments. So we need to access our command line and take the arguments, then put them here. So not really arguments, but our file path, so just one argument. But let's see if we can pass arguments as part of starting the function. So we need to, let's let's see what this does. So let's say cargo running from hello.text. Could not find, did I? Okay, sorry, I need to open this, so I have to close this so we're not distracted. I was running this from the main projects folder, so it's supposed to be here. So as you can see, the first argument at index 0 is default, is the name of the program. There's a reason why this is here. Why the second one is what we pass. So this is necessary for you to know the source of the program, and for other purposes. Let's not go too far. But here, as you can see, our argument is saying whatever you pass goes there. Okay. So now that that's said, let's our next step is to take a file path. Let's get our file path out of here. Okay, so we're going to write the function, and we should give it a name that is that points to what it does. So we want to get the file path. Take a file path, get file path, two spellings. Okay, file path. Yep. So what does this function need? It needs to get a collection of string. So let's name this parameter argument or args as well, which it doesn't matter if it's here. There are different functions. So what type is this? It's a collection. It's a reference to a collection of strings, right? So a reference, not directly a vector of string. So if we do vector of string, this is going to be transferring ownership from the caller to this, and not really something we want to do. So we stick to this, and because this function can fail or pass if the user enters an argument. That's fine. If the user does not enter any argument, or if the function is called without an argument, then it's going to be a problem. So we need to handle the error. This is where Rust is very good. It helps very well in handling errors, all of the possible errors. So because we are going to be handling an error or success, we need to use the result type or the result enum. So there is an OK which shows success, there's an error. So whichever one you get, whatever you get, you put it or wrap it inside of the branches. So if we get a file path from the program, let's return that as a string. That's the success string. And if we get an error, we return the error back to the caller. So our error here is not gonna be big. It's something we just put into the program. So this is a static string. It's known at compile time, so we can just set it there. Okay, so the argument we are passing is this, and what the function is returning is this. it's either it's a success or a failure. So first of all, we need to check what would cause our error, or what we want to define as an error. So for me, the error is if there is no argument passed. I don't want to check if the argument is right or wrong, if there's no argument passed. So, and that's where we check the length of the collection. So we say if the argument, we could actually name this argument. Okay, argument, since it's not one. If the args dot length is less than, we have the index 0 and index 1, so that's 2, is less than 2. What do we want to do? We want the program or the flow to stop and then return the error to the caller. So we use the return keyword, okay, and what are we returning? An error. Always remember, you wrap the case for that result inside the type. So because it's an error, we wrap it inside an error. If it's an a success, we wrap it with the OK. So what type does this error take? It's a static string. So this is one way we do the static string, just inside double quotes. So what would be this error? It's going to be no arguments entered, or that makes sense, or incomplete arguments. No, let's just say no 5 parts. So this looks no 5 parts entered. Yep, this makes sense. So if we get an error, this happens and it goes here. But if we don't get an error, what happens? We try to store the 5 part and return it as a string. Okay, we're using a string here because it's not known at compile time. During runtime, the program gets the 5 parts. So let's say let 5 parts, whichever 5 parts, doesn't matter. Let 5 part be equal to, since we access our arguments index index 1. Yes, that's where our 5 part is. That's all, and we return it inside the success, which is the OK. It's on the 5 parts. That's a string. So we have an error here, cannot move out of type string. A non-copy slice cannot move out of here. So unlike integers that have the copy trait, string does not. Okay, string does not. So we could do something here. Instead of borrowing, if we borrow here, we have another error here. So we expect, the function expects to return a string, but we are returning a reference to a string. So we could do the toString here. That works. See, converts the given value to a string. That works. Or we could remove this and then do .clone. If we do this, it also works, but we have to take this out, so we're not string. Whichever one. This is not bad because the input is very small, just a 5 parts, and yes, we have our function ready. So let's call this function. What are we getting? We are getting the 5 parts. Okay, let 5 parts we do that in main. Let 5 part be equal to function get 5 parts. So the name makes sense. Let 5 part equal to, we call get 5 part, and get 5 part expects us to pass a reference to a collection. So right now this is not the reference, we are moving args. So we add the ampersand to borrow it or make it a reference. So because this is a result type, we need to try to handle the error. We can do that using match 5 parts. So depending on what you get, so okay, you can say value, and then whatever value is, we can return value itself. You can see it's a string. Same thing with the error. So we can do that as E and then return it. So but we are going to do we're going to use a method that is available on the result type, which is the unwrap. There are so many, but most of these panic, so we won't use them because we want to make our program handle error properly instead of panicking. So we're going to use unwrap or else, because if we do not get the OK value, we want to compute the else value, which is our error. So we create a closure here. It's like an anonymous function. So the parameter we are passing here is error, just so we compute the else part. So what happens here is we print the error to the standard error, and the error has already been set from the function. So when you call it, this goes okay. So but because this function expects a string, what we are doing here is just printing to the output, does not return anything. So we want to return something, but also stop the program from running here, like stop the process. So we use the process module from the standard library. So we could do it as this, use std and then process. Okay, that works. And now we can call exit with 1. So it could be 0 or 1. 0 is for success, any other thing aside 0 is a failure. So now that we have our 5 parts stored somewhere, let's try to print it. Okay, 5 parts. As you can see, it's a string. So let's see if we can print the 5 parts, whatever we pass. So file parts.txt. So let's just, as you can see, we have our 5 parts. So let's start the program with no 5 parts. So no 5 parts entered. We have handled that error. So whichever thing you do, there's something for it. So now that we have our 5 parts, what should we do next? If we have our 5 parts, we should try to read the file from the 5 parts. So that's our next. It's also going to be a function, so we are making our program modular. every function has a specific job. So let's call this function read file. And what does this expect? It expects a file path. The file path is a string. The file path is a string. We're going to remove this. The file path is a string, but we are going to be taking a reference to a string, so we do not have to move it. So this is going to be coerced even if we pass a string here or a reference to a string, no problem. Okay, so this function only needs the file path. And what does it return? So it's supposed to return the content of the file or not. So we are going to either get something to work or there's a failure, and we are going to use the result type again to handle this. So if we are able to get the content of the file, it just returns it as a string. Okay, now we're returning it as a string because it is not known at compile time when the program is started runtime. So the file path is now passed. So a function is not most times you don't return a reference to a string in a function, like from inside the function, because it's gonna be dropped. That's where the borrow, checker problem and co comes in. So if we get the file path and read it properly without error, we return it as a string. But if we don't, we get an error. So because this is a runtime thing, the error can be anything: file does not exist, file permission issue, directory, multiple errors. So we need to use a heap allocated error. We use this box, and the error is going to be dynamic, so we use the dynamic trait and call error from the standard library again, the error module. So if you come here, you can see there's error, and then the error trait. So this is also is a trait, dynamic, dynamically dispatch. So to use the trait this way, it must be DYN compatible. So we have a function set up to take what it needs and return what we expect. So now we should try to handle the error. So what should be the error? Are we able to read the content or not? If we are able to read the content, great. If not, it's an error. So let content equal. So because we are going to be accessing the file system of our environment or PC, we need to use the standard library file system module. So we do fs. So this use standard library fs. So as you can see, fs has been added here, but we can separate them if we want. So use this, depends on whichever one you want. So just, if we don't get to type that, they all would appear in a different way, just in a bracket. So inside of our file system, you have different methods here. So the one we're going to use is the read to string. So read to string also returns a result type. It returns the result as a string or an error, so it can fail or not. Most of them, or almost all of them, return the result type. So if you look at it, it gives you some extra details. So we're going to use this. As you can see, it says read the entire contents of a file into a string. There are others you can explore. So read to string expects us to pass a file path. So we use our file path here. Since this is a reference already, no need to add this. Okay, as you can see, it's a reference to a string. So because this is a result, we can do a match content, right? And then read to string, and then if it's okay or something, sorry, if it's okay, you can put the value and then return it, but we use the shorter, more idiomatic way. So we just add a question mark here. So this question mark operator does this. Let me explain. So what it does is it tries to do this, and if there is an error, it returns the error, it propagates the error, and the program stops running. So we don't need to do the return here. No, it automatically does that. Okay, and the error can be dynamic, so we do not know what the error might be. But if it's a success, the value is now turned to this. It's now passed to content. So our variable takes the string, as you can see. So it's no longer showing result, but if we remove this, I think we're going to be having a result here. Yes, as you can see, result. So but with this operator, this is a okay, as a string error comes here. So now what we do next is, okay, did we get this to work? We wrap it in a success case. So we put the content inside the success, and that is it. Instead of plenty match and just make it short. But note that this should or can only be used if the return type of the function is a result, if the function returns a result. So if it doesn't return a result, it won't work, because there should be a place for an error or a success. So we now have our function set up. Let's try to use the function. So say let content, let's call this content equal to read file. This is ours, and it needs a reference to, as you can see, a reference to a string. So if we use the string here, we would have been getting an error. Okay, so because this is a result type, we need to handle the error as well, or the success. So we use the unwrap or else again, and have a closure, call this error as well. And then what happens if we get an error? So because this is a statement that evaluates something, a statement always have the semicolon, but an expression does not, like this. So no semicolon, this is automatically returned here. But if you add this, I think we're going to get an error. As you can see, remove the semicolon to return this value. I like Rust's error, the way it handles or tells you about errors. It's descriptive most times. So what happens if we get an error? We want to print to this standard error, and the error is known at runtime. So this is where it goes in, and then we also need to return something actually, but we don't want to return anything. So this I don't know if I mentioned it before, but this returns what is called a never type. It does not return anything, but it promises to return something. So you can walk anywhere you need to return something. It fits in automatically. So this actually expects us to return a string or this, but this is none of that. So, but it still works. You can read more about that for to get more understanding. So we now have this setup string because we have unwrapped it. Let's see if we can see whatever is passed there. This should be content, and let's test, because that's very necessary, unless you're so sure of what you're doing, but it's always good to test. So test.tt, this is wrong, so let's see the error. No such file or directory, that's the error expected. The program did not panic, it just exited with a clean error. Okay, so when handling all of these errors, you can do this as the color, just to make it look fine whatsoever. So let's try this again. The error, no such file. So let's do something that works. txt test.ts, that's correct. So as you can see, our file has been read. Okay, so we are good to proceed. So now that we have a function that gets the file paths and read the content, the last thing we want to do is, according to attack prints every line that appears more than once in the file, along with how many times it appears. So we need a function that does this too. So what do we call this function? We call it find duplicate. Sounds like an active word. Find duplicate. Verb is doing something, just like here, read file, get file paths. So the names should always make sense. Okay, so what does this need? It just needs a string. Yes, a file, a string. So let's call this a file. It's a reference to a string as well. Okay, because that's just what we need. So because let's also do some error handling here. So if we are able to read the string, we just print we just print to the standard output. We just print the check, so we do not return anything. So that's why I do this. This is the unit type. It says nothing, but something happened, but I am not returning anything back to you. I'm just showing it to you. Okay, just like pressing a button and your TV turns on and then pressing a button, and you get an ice cream. So one shows you something as proof of something happening, and the other one gives you something also as proof of something happening. But here we're just turning on our TV to see the output. So if we get an error, this can be a static string. Okay, this can be a static string because we know what could go wrong, or we want to just say we know. Okay, so we can actually not return any error or do anything, just print it out. The caller can handle the error. So this is where we remove the whole of this return sections. But the error here could be let's just do it. It's part of exploring things. The error here could be what if the file is completely empty. So we're going to be using an if statement again. So if our file is empty, okay, if this is true, we want to return an error and wrap it inside an error type. So we say file is empty. File is empty. Come on, nothing to search. File is empty, nothing to search. That makes sense. Simple. So if not, we proceed. So if file is not empty, what do? We want to look at the file, find the duplicates and how many times they appear. So this is going to we're not returning anything but printing something out. So let us store the results somewhere before being printed. So we're going to use the hash map because this allows us to have a key and a value. So the key here is the duplicate line and the value is the number of times they appear, the duplicates. Okay, so we're going to use the hash map, and we can use it by importing it from the standard library. Collections. So it should be hash map. Hash map. So let contents, or result, whichever, let contents equal to a hash map new. So this is of associated function. Okay, so this is a hash map. So what do we do? We can actually just put this here. So this is covered. That's at the end of it. So this wants us to include a type and notation of the kind of data that the hash map will take. This will be known at compile time. So we could say this can be a hash map. The key is a string, whichever, and the value is an unsigned 32-bit. So this now looks okay, but this can also be inferred by whatsoever we pass into this. So this is just like vector, like saying vector new. Let's file equal to vector So it can be just the same way as you do string. The string has new as well. Okay, so new string. So yeah, but we're using a hash map here. So even when you're setting up your own function, you can add this using the implementation flag. So you add methods for your struct or whatsoever, or your type. Okay, so now that we have a place to store whatever we find as a duplicate, let's work the logic. So if you have the steps written out, which is always advisable, okay, we say goes every line and prints the line as well as how many times they appear. So we do a loop. So for line in contents, the content, we are looking at the file. File for line in file dot lines. So this says for every line in this file. So this is an iterator. It goes through each of the lines in this string file. So for line in all of the lines in this file. Okay, so that's what our loop is saying. So for line in file.lines, what should we do next? So we call our contents dot. We use the lot of it. You can go through them, see what it does, and when you have a problem, you can figure out which of them would be necessary. So but I am familiar with this because I've used it before. Okay, just looking at it, the example here would also give you a clue. So what entry does is it gets the given keys corresponding entry in the map for in-place manipulation. So it checks if this line, each of the lines, so since the loop, it checks if the line is in this content. If it's not, so we place this key as our line here. So if it's not, we call the and modify. Okay, and modify. So if we find the line, it has two hands. One is the line is found. The second one is not found. So just like saying the room is occupied, second one is vacant. So depending on the part that is true, the chain continues. So we are chaining methods here. So if it's found, okay, modify. So modify, we need to have a closure here as well. So what happens? Let's modify the value. So let's call it count. This is like I said before, this is a closure, an anonymous function that performs an operation. So we say count. As you can see, it's a mutable reference. Count, what do you want, plus equal to 1. So if the entry is found, you increment the value by 1. Count plus 1. That's why you have and modify. But if we don't have the value, so we use the insert or insert. So ensures the value is in the entry by inserting the default if empty. So if it's empty, so this is the default value. Okay, if it's empty, this is the default value. If we save this, it now arranges itself. So so like I said, let me explain this one more time. It goes through each of the lines in the file and checks .entry checks if the line is in the contents, the hash map as a key. If it's found, if it's vacant or occupied. So if it is vacant, this is now added. So the space, it now adds the line and puts 1. Okay, and puts 1. But if it's not vacant, it's already there, it increases the value by adding 1. So just 1, 2, 3, like a counter. Okay, so we have an error here. So this is supposed to be a mutable reference, so I32. So if we put or insert can be anything. So depends on the closure, it can be anything, but they should match. Okay, so they should match. If it's an integer, it should be an integer here. If it's a string, it should be a string here. So let me just try that. I want to see. So let me say hello. So this and modify. I haven't tried this before, but let's not make this long. I'll do it later just to be sure, but I think that's what it should do. So the types should always match, because if you annotate it here, that's how it is. So it should be string as the key, U32 as the value. So it stays like that. So the data can be the same. This is 1. Okay, so because this is a mutable reference, we have to add the mute here, because this will be changed, this will be modified. So we also dereference this. So dereferences means we are not just looking at the reference, you are going directly to the integer and manipulating it, not just reading or borrowing the value. As you can see, we no longer have the error, but if we remove it, we now have the error. So let me put it back. Remember, this is for dereferencing. Okay. There's a description here. So dereferences the value, okay, from a reference to the value itself. So now that we have the duplicates added here, so let's try to print. We do not have the duplicates added here. Sorry, we have all of the lines added here, but the ones that appear more than once have a value according to the number of times they appear. So that's why we use the hash map, because it helps us put data that can have duplicate, and we still know how many are duplicate instead of repeating values. Okay, so let's assess our hash map and see what we have there, but only show the duplicate. So as you can see, without the annotation, it has inferred that this is what it should look like. This is what it should be. Okay, so let's go through it. So we say so we are going to have a tuple. We're going to have the line as the key because we are accessing the hash map, the line as the key. We are accessing the hash map fully, the line as the key, the count as the value. Okay, for line in content. So you just need this to be a reference. Okay, if count is greater than 1, so we are looking at the values that are more than 1, because those are the ones that are duplicate or appear multiple times. So if the count is more than 1, we want to print it out. Yep, that's what we want to do. So we want to print the line and the count. So we say let's put this so it looks, yep. So we want to print the line as well as the count. So this is a reference to the count. Okay, so let's save this and see why we have an error. If count, consider the reference in the borrow. Okay, let's oops, now we no longer have an error. Okay, because this is not a reference, we are actually assessing. So we are not just reading the value, we are actually assessing it so it can be compared. Okay, so it can be compared. That's why you have to do reference. So now that we have the find duplicate set up, let's call it in our main. Okay, we don't need to print content. So because this does not return anything as the okay, only error, let's just focus on the error, right? So we say if let error, okay, let's call the error or err. If the calling this function, the function is duplicate. Yeah. If calling this function, that's the if let. If calling this function returns an error, the function requires us to pass a reference to a string, right? Yes. So our reference string is content. Yep. So if calling this function returns an error, this is what we do. We print the error, nothing else. And that error is err. What is err? Static string. Yep. And we can also just end the program as well, exit it as well. Okay, so we are good. This can also be okay, but if you want to do the okay, that's when you use the unwrap, so that it's going to be stored somewhere. And now we need to do have it stored in a variable. Say variable, if let variable be equal to find duplicate, you pass in content, but this does not return anything. Oops, what am I writing? If let variable equal to blah blah blah. So this does not return anything. Just if you unwrap it, what are you unwrapping? Nothing. So it's just nothing. So we have it all set up. Okay, so we have the file part, the content, and we read it and try to get the duplicate. So let's try again. Cargo run text.cs. We want to have an error. So error, no such file exists. So test.txt. You want to get the real file, read it. So as you can see, orange appears twice, banana thrice, apple 4 times, pear, mango 4 times, avocado 2 times. So if as you can see, if you go here, you see that we are right. Orange 1, 2. Is there any other orange? No. So orange appears 2 times, mango appears 4 times. So if you check 1, 2, 3, 4, yep, avocado 2 times. So if we clear this and save it, so we want to see if our error here is going to be reached. So it's still the same file. You can see file is empty, nothing to search. So if we do not have this error here, we just have our function do what it needs to do. The caller can handle that here. In main, the caller can handle that here and check if the return type is empty. So then we need to return a string here, but our function does not. Our problem did not ask us to return a string, but just print every line that appears more than once. Okay, so I think we are done. We've tested the function, everything works well, and I hope everything is clear. So like I said, this is for beginners. That's why I had to be explaining why, how, and what. So this is a simple program, but because we want to make it very robust, handle error, work properly, it's up to 69 lines. We have our main, where we handle all of the calls. It's very simple. You can read it and understand what's going on. Then we have our functions that do their jobs. So one gets the file part, another reads the file, the other find the duplicate. So each one has its stacks. So that's also why if you go down, we have the chaining. So this does something, and whichever result it gets, it passes it to the next one. Same thing to the last person. So if something goes wrong or it's not the part that needs to be done, it can be skipped. It's the same thing if a function is called and it's not true or it's an error case, it moves to the direction of the error, which is this. It shows the error. So like I said before, you can just add error here if you want, just to make it clean. It's up to you, but at the end of the day, you should have your function doing exactly one thing and not multiple stuffs. So if you are an absolute beginner, you might find yourself having all of this inside of main, so you just be moving from one place to the other. But when you start growing, making your code modular, you now separate them, and then you can also have a library. So this is where we move all of these functions into a lib.rs file. Okay, so when we have it in a library.rs, we make it a public function, so it makes it accessible from outside. But since we have it here, no need. So if we have it in the library.rs file, we would also do the use thing. So we call use, we type the part of our program, right, and then import the function or module depending on what you have. So when we import them, we can now we won't have all of this. This is just what we are going to have. The only thing we will have is just this main, very clean. Okay, that's just what we are going to have, just this main. We call same thing like we have here. So because these are all external codes, we do not need to know how they work, their logic. Nope, we just call them and pass values. Okay, the same thing, this can be hidden in our lib.rs. We just call them and they do their job. Only thing you need to know is what does the function need and what does it return, so you can give it what it needs and then handle what it sends back. Whichever way you want to handle them, it's up to you. So thank you so much. If you watched up to this point, I hope I was able to explain as much as possible and you understood something. So you can take your time. This is the problem. You can take your time. This is the problem. Try to write it on your own by yourself. If you have any issue, pause, take a break, do some checks. Don't ask AI to write it for you. You can seek for help, look at the methods, do it one step at a time, and understand why you're doing this, what happens if you do it this way or the other way. So just like that, and you see yourself getting used to some of this. When I started, I wasn't this confident, but now I could really just code and record myself. So thank you so much once again for watching up to this point. When next time I'm solving another simple beginner friendly program or task, I am going to record it again and upload. I hope you have a great day ahead. Bye.